So when we think of multiplication, we're thinking groups. So to have two groups of 3, we have one group, two groups of 3. 2 times 3 equals 6. I have 6 positives in there. Now, if we have negatives, if we have 2 groups of -3, it would be the same. I've got one group of -3 right here. I've got another group of -3 right here. So this would be 2 times -3. And I have a total of 6 negatives. So that gives me -6. Now this is where it gets a little tricky, because if we have something like -2 times 3, and we're saying, well, that's -2 groups of 3, how do we model a negative group? It's actually really tricky. So if we say we have groups of 3, 1, 2, 3, 1, 2, 3, but how do we show that this is a negative group, like an ungroup? Well, maybe now I could show you, oh, I'll make it in a color, like this is a negative group. This is a negative group. It's not a regular group, it's a negative group. But it gets confusing then, because what does a negative group mean? Well, it's kind of like the Twilight Zone. Anything inside a negative group is going to flip around and be opposite of what it was. So if it's in a negative group, it's flip-flopping around. So when I have -2 groups of +3, I'm going to end up with 6 negatives. It equals -6. Now I can show you this right here, but it's really hard to draw. So you often don't see negative groups. If they give you a negative as a picture, like on the SOL, the negatives will usually be the counters and the groups will always be positive. All right, so my table's getting a little messy. Sorry about that. So the last thing we got to talk about is, well, what if I have -2 groups of -3? So that's like -2 times -3. Okay, so we have these groups of -3s, right? Now, the thing is, these aren't regular groups, these are negative groups. Ooh, it's a negative group. It's not a regular group, right? So, inside a negative group, it's like the Twilight Zone. Everything in there switches to the opposite of what it was. So all of these negatives, since they're in a negative group, flip to the opposite of what they started. So when I take that negative group into account, what am I left with? Well, I have 6 positives. So -2 times -3 is going to be a +6. All right, so it's time for our notes, and we're going to learn about multiplying and dividing integers together, because we know that multiplying and dividing, they're fact families. So the first thing we want to make sure that we know is all these different symbols for multiplication, from the X to the star to the dot. Knowing that parentheses with no other operation does mean that we're multiplying. We should also be familiar with these other ways to represent division. All right, so when we look at a number line, what we're going to see is we're going to see repeated addition. We're going to see that they're going the same amount each time. So for this one, I see that they're going +2 spaces, and they're doing it 4 times. So I can say that that is 4 groups of +2, and that ends us here on 8. Now, we're going to think fact families when we think of this. So it would be fair to say that this is 4 times 2, but it would also be fair to say that we have 2 times 4 equals 8 as well. Now, for division, normally you'll actually see division going the other way. You'll see it going out and back into 0. But for the sake of our notes and our fact families, we're going to just use the same image. So if we start at 8 and we have 4 groups going back, we have 8 divided by 4 equals 2. Or you could also say that 8 divided by 2 equals 4. So you can take a picture like this and say that these different fact family equations are represented within this image. Okay, so we can continue on for the rest of these. So I have 2 groups and each of them are moving positive 4. So I could say that's 2 times 4 equals 8, or 4 times 2 equals 8. If I were to go from 8 down, I've got that 8 divided by 2 equals 4, or 8 divided by 4 equals 2. For this one, I see that I'm going to the left. So each one of these groups is representing negative 2. So I can say that I have got 1, 2, 3, 4 groups, and they are each going negative 2. 4 groups of negative 2 ends us here on negative 8. Now, it would also be fair to say that negative 2 times 4 equals negative 8. Notice how I'm keeping the 2 negative because that's how many it's going in the negative direction. I have 4 arrows regardless of which direction I'm going, but the 2 is representing the negative. So when it comes to my fact family, I can say that negative 8 divided by 4 equals negative 2, or I could say that negative 8 divided by negative 2 equals positive 4, because there are 4 arrows. The number of arrows is not negative. Okay, so looking at this one, I have 2 arrows, so that's 2 groups, and each of these arrows are negative 4. So 2 times negative 4 again lands me on negative 8. I could also say it in the other order, that negative 4 times 2 equals negative 8. Notice I'm keeping the 4 negative because that's how many I'm going in the negative direction. There are 2 arrows. The number of arrows is not a negative number. When it comes to division, I'll just rewrite these as fact families. So I have negative 8 divided by positive 2 equals negative 4. I can also write negative 8 divided by negative 4 is equal to positive 2 because there are 2 arrows. So looking at this one, I have 1, 2, 3, 4, 5 arrows. The number of arrows is positive, and each of them are going negative 2. So 5 times negative 2 equals negative 10. The other way I could write that is by flipping the order around and saying I have negative 2 in groups of 5, giving me negative 10. And I'll rewrite those division fact families. Now normally, again, division starts out and works its way in, but for the sake of saving paper, we're going to just use the same image. So we can also say that negative 10 divided by positive 5 equals negative 2. We can also say that negative 10 divided by negative 2 equals positive 5. All right, looking at this one, I have 1, 2, 3 arrows. The number of arrows is my positive, times they're moving in the negative direction. So that gives us negative 9. And I could also say negative 3 times 3 equals negative 9 because I'm just reversing this order. So the fact family would go negative 9 divided by negative 3 equals positive 3, or negative 9 divided by positive 3 equals negative 3. For our final one, we have 2 groups. So the positive number is 2 because that's how many arrows, and each of them are going negative 3. That ends us here on negative 6. It would be fair to rewrite this as negative 3 times 2, giving me negative 6 as well. My division fact family then would be negative 6 divided by 2 is equal to negative 3, and negative 6 divided by negative 3 equals positive 2. You may have noticed that on this paper I never did a negative divided by a negative, because with this illustration it's really hard to show that the arrows would be negative. So the arrows, the number of arrows, represent the positive number. The direction on the number line tells you if it's positive or if it's negative. Again, it is very hard to show a negative times a negative on the number line, so you most likely will not see that in any sort of test question like on the SOL. we're going to continue thinking about fact families as we work on using counters. So you'll see that we already have the models done for us, and we're just going to take a look at how things go. So the number of groups is always going to be represented by a positive number. So here I have 2 groups, so that's going to be 2 times however many are in my group. There are positive 4 in my group, so 2 times 4 equals 8, and I see I have 8 positives. I could also write that flipped, so I could do 4 times 2 equals 8, because that is just a related fact family fact. Now for division, I could take the same thing. I started with 8 whole counters, and I split it into 2 groups. There are 4 in each group. Or I started with 8, and I split them into groups of 4. That gave me 2 groups. Now this one, you'll notice, is very, very similar, only instead of being grouped this way horizontally, they are grouped vertically. So this is saying I have 4 groups with 2 positives in each. And again, I can flip that around because it's a fact family. And because these are all positive, these are going to look very, very similar. Now here we get into some negatives. Here I have how many groups? I have 4 groups, so the 4 is a positive number. I have 4 groups of -2. That leaves me with a total of -8 counters. Now I can rewrite this in the other order because this is indeed a fact family. So I could put the -2 first, and that is still fine because the 4, my number of groups, is positive. Now for division, I'm taking -8, I'm dividing it into 4 groups, and each group has -2. I could also write that in the same family. I have -8. I'm dividing it into groups that each have -2. That gives me a total of 4 groups. Now again, this is the same thing, only it's split differently. But because we do have negatives, the order does kind of make a difference. Because here I have 2 groups, so the 2 is a positive number. I have 2 groups, and each of them have -4. Now in the end, I still do have -8, just like here, but notice how here the 2 is positive because the number of groups is 2, and the number of groups is always your positive. Now I can flip the order around because multiplication does have the commutative property, so I am able to flip around the order, and it's still showing the same fact family because the 2 is both positive here. And I'll write this the other way. -8 divided by into 2 groups gives me groups of -4, or -8 divided into groups of -4 gives me 2 groups. Okay, positives again. So positives are going to look very similar to each other. So here I have 2 groups of 5 positives, which give me +10. So I can rewrite that using the commutative property. And then for division, I could say, okay, 10 split into 2 groups gives me +5 in each group. 10 split into groups of 5 gives me 2 groups. And it's going to look very similar because both of these numbers are positive. So here I have 5 groups of +2 equals 10. Use the commutative property to write it in a different way, although it looks very similar to before. So 10 split into 5 groups equals groups of 2, or 10 split into groups of 2 equals 5 groups. Now we've got negatives, and negatives do make a difference. So for these negatives here, I see I have 2 groups, so my positive number is 2. I have 2 groups, and they each have -5. So 2 times -5 equals -10, and I have 10 negatives altogether. I'll use the commutative property to rewrite that in a different way. Now for division, I can still use these fact families. So negative 10 counters split into 2 groups gives me negative 5 in each. Or I could say that negative 10 counters split into groups of negative 5 gives me 2 groups. The number of groups is positive, the number of negative counters is negative. So here, although it's both negative 10, they split it differently, and with negatives it does make a difference. So for this one, I have 5 groups of negative 2, giving me negative 10. The negative 2 is negative because there are negative 2 in each group. The number of groups is positive. I could also use the commutative property to write this in the other order. Now I can use my fact families. Negative 10 split into 5 groups gives me groups of negative 2. Or negative 10 split into groups of negative 2 gives me a positive 5 groups. The number of groups is positive. The counters in each could be positive or negative depending on what kind of counter they are. You may have noticed here that we never did a negative times a negative in here because I mentioned earlier it's very hard to model a negative group. So whenever you see it on paper, like on a standardized test like the SOL, the number of groups is going to be represented positive because it's very difficult to draw a negative group. Now, in addition to modeling using counters and number lines, we can also just think about how these rules make sense because we know that multiplication is repeated addition. So when we have 2 times 3, that's like doing 3 added together 2 times to give us 6. Or it's like doing 3 groups of 2. So adding 2 together 3 times to give us 6. So if we think of it with a negative, 2 times negative 3 means I'm adding negative 3 2 times. Well, that gives me negative 6. I can also think of it as doing 2's added negative 3 times. So I'm saying, okay, I'm adding together 2's. Now it's not just 3 times, but it's negative 3 times. So everything in these groups gets flipped around. They were positive, now they are negative. So it's negative 2 plus negative 2 plus negative 2 because it wasn't adding 3 times, it was adding negative 3 times. It's kind of one of those Twilight Zone, it flips everything around kind of things. Still gives us negative 6. Okay, now for this one, it's not just 3 2 times, it's 3 negative 2 times. So if I'm thinking of those negatives, I'm going to invert my groups. So these positives have now become negative. So negative 3 plus negative 3 is negative 6. Or, logically, we've got 3 groups of negative 2's, giving us negative 6. When I have a negative times a negative, so that's like saying I have negative 2 groups of negative 3. So I have negative 3 and negative 3. That would be 2 groups. But since these are negative groups, I invert these. So now it's like they're positive. So positive 3 plus positive 3 is positive 6. Or I could say it's like negative 3 groups of negative 2. So negative 2 plus negative 2 plus negative 2. Now this would be 3 groups, but I need negative 3 groups. So to make these groups negative, I invert the sign. I change it. It was negative, now it's positive. 2 plus 2 plus 2 is positive 6. Now when you look at these answers here, what you may notice is when they are both positive, your answer is positive. Now the other way to get a positive answer is when they are both negative, which is very different than the rules for adding and subtracting. When you multiply integers, if the signs are the same, they are both positive or they are both negative, you get a positive answer. See this key guy? The signs are the same, answer is positive. Now we get these negative answers when you have a positive and a negative or a negative and a positive. So when the signs are different, you have one positive and one negative, or one negative and one positive, that means your answer is going to be a negative answer. See, they're different. They almost look like they got beat up. They're sad. Negative answer. Using the rules we just talked about right here, we can use a shortcut then when we are solving our math problems. So, a positive times a negative. A positive times a negative is going to be negative, so this answer is negative. A negative times a positive is going to be negative. The signs are different, the answer is negative. The signs are the same, two negatives, the answer is positive. The signs are different, a positive and a negative, my answer is negative. So I've already determined the sign, then I just multiply like regular. So I have 4 times 9 is 36, so this answer is a negative 36. I have 4 times 8 is 32, so this answer is a negative 32. 5 times 3 is 15, so my answer is a positive 5. 20 times 90, so 2 times 9 is 18 with 2 zeros. So I have negative 1,800. Go ahead and using this shortcut, complete the rest of this page. What if there are more than 2 factors? Well, I want to tell you a little story about a party in Mathland. So, once upon a time in Mathland, there was a party. A bunch of positive dudes went together to have a party. And when there's a bunch of positive dudes at a party, the party is awesome. It is a positive party. Woohoo! Now, once upon a time, at this awesome rockin' party, shows up a guy named Negative Ned. And Negative Ned is miserable. He is so negative. All he does is complain, complain, complain. So when Negative Ned shows up to a party, he walks around and he talks to every person he can find. And he complains and complains and complains until everyone is so tired of listening to poor Ned complain that they are now too very depressed. And he ruins the whole party and turns it into a really negative party. Negative party. Now, once upon a time, there was a party in Mathland. When there's all positives, it's a really positive party. Well, one day, Negative Ned shows up. But just as he shows up, also, another negative friend shows up. Negative Nancy. Now, Negative Ned and Negative Nancy start to complain because they are negative people. Negative Ned complains to Negative Nancy, and not to be outdone, Negative Nancy complains to Negative Ned. So he complains, and she complains, and he complains, and she complains, and they keep on complaining because complainers love to complain. And while they are busy complaining, they are actually feeling pretty good about complaining because that's what they like to do. And nobody else at the party can be bothered because they're worried about themselves. So this party remains awesome. It's a really positive party. So when you have one negative, it ruins the whole thing. It makes a negative party. But when you have 2 negatives, the party is saved. It is still a positive party. Now, the rule continues to work. So, if we have all positives, it's a positive party. If we have 1 negative, the party is ruined. If we have 2 negatives, the party is saved. They complain to each other. If we have 3 negatives, we've got a rogue negative, he ruins the party for everyone. But if we have 4 negatives, the party is saved because these guys can buddy up now. 5 negatives, negative party. 6 negatives, the party is saved. So, if you have an odd number of negative dudes, it's going to ruin the party in Mathland. But if you have an even number of negative dudes, your party will be saved and the whole party will still be awesome. So the moral of the story is, if there is an odd number of negative factors, then your product is going to be negative. If there is an even number of factors that are negative, then your product is going to be positive. Using that rule, you can go ahead and use a shortcut to solve these multiplication problems. You may have noticed this already, but the shortcut for dividing integers is the same as it is for multiplying. Signs are the same, our answer is positive. Signs are different, our answer is negative. So when we think about integers, adding has its own special set of rules, and subtracting is related because we can turn a subtraction problem into an addition problem. The rules for multiplying and dividing are completely different from adding and subtracting. However, the rules for multiplying and dividing follow the same pattern. Using these rules, go ahead and use the shortcut to answer these problems. Congratulations! Now you can continue working on practicing modeling and solving multiplication and division problems.